Welcome to episode 17 of the Norton Nemesis 1500cc V8 rebuild. In this episode, I'm going to be replacing the original rotary throttle valves with more modern Honda throttle bodies and also fitting a new ECU. While I was rebuilding the engine and the engine was on the bench, I decided to make some new inlet manifolds to fit Honda CBR throttle bodies just in case the original rotary valves didn't work because they were proving problematic and difficult to tune. So I decided to lock them in a fully open position and fit my manifolds. The first thing I did was cut out some 6mm thick aluminium plates to fit onto the engine and line up with the original mounting bolts. The original throttle tubes will be locked in the fully open position and sealed at each end. Here's the CBR600 38mm throttle bodies that I chose. These should be just perfect for the engine and looked really good. The next thing I did was cut off 8 pieces of aluminium tube and shape them to fit onto the inlet manifolds so they point to the right direction. The spacing between the ports was virtually identical, which made it much easier. So I put the tube on a milling machine and milled the angle to suit. I used 6082 T6 aluminium for this application. It's perfect for welding and it machines really nicely. Some of the mounting holes are very close to the side of the inlet ports, but using M5 caphead screws there should be just enough clearance. I find it really enjoyable using a hand-operated milling machine. Turning both handles at the same time to interpolate a circle is great fun. Here we go, that's the last inlet port roughed out. So now I can put the throttle bodies on and see how it looks. And it looks really nice. I'm really pleased with that. I'm really pleased I decided to make these new inlet manifolds last year whilst the engine was still on the bench. It would have been really difficult to do now with it in the bike, making it fit around all the frame. So now it's just a case of removing the old airbox and replacing the new parts. The new inlet manifolds and inlet throttle bodies fit nicely between the frame. It looked almost perfect as if they've been there like it all the time, which is really pleasing. I then made some stainless steel gauze covers for the throttle bodies. And also a larger aluminium catch tank on top of the rear cylinder bank. The original catch tank was too small and allowed oil to go over the top into the inlet manifolds. This is what caused all the smoke. So now I can remove the old ECU. Each of the new fuel injectors is connected up to the wiring loom with some snap-on connecting plugs. And the throttle position sensor has a similar plug as well on the side, along with air temperature sensors and coolant temperature sensors. This all has to be connected into a new loom that I've got to make. To make the new loom, the first thing I'm going to do is make the 12-volt feed to the fuel injectors. I'm really excited to look in this box. This is the new ECU system from Canems, but we'll open that in a minute. I bought these new snap-on connectors for the fuel injectors to replace the original Honda ones, which are all soldered up. These are really nice. The wires clip in the back, but I'm going to be soldering them as well just to make sure you get a good electrical connection. The connectors are supplied all stripped down in their component parts. So this is the clip that goes onto the end of the wire that makes the connector with the fuel injector. These are crimped in place, but I'm going to use a bit of solder just to make sure. And this is the rubber plug that goes over the wire to seal it from water. So the first thing I do is get my red wire and lay it over the bike and cut off some rough lengths to feed each injector. I can trim it to the correct length later on, so it's not a problem. I then trim back the insulation, twist the wire together and put on the connector. The connector is crimped in place with a special 3-stage crimping tool. With the connector crimped onto the wire, I solder the joint just to make sure. There we go, that's just perfect. I can now push the connector into the connector block. It snaps in place with a click. I can now slide the rubber seal along the wire up to the connector block, pushing it in tight to make a waterproof seal. It can be a bit fiddly, but it gets in there eventually. I now repeat this for the remaining 7 connectors. Soldering on each connector in turn. It's now time to unpack the Canems ECU. I've been really excited about this for quite a while, but I resisted the temptation to open the box until I need it. So here it is. The first thing you see is a load of wire and quite a comprehensive manual telling you how to connect it all up and wire it up and program it. This is a couple of pages I'm most interested in for now, a schematic wiring diagram and a colour code for the wires, telling you which wire does what and where it goes. I also got a little crib sheet as well for the specific application on the V8 Norton, which is really nice. So here's the main wiring loom. It's about 1.5 meters, 2 meters of wire, all coiled up together. There's so many wires, but they're all different colours, so that makes it quite easy to identify. And here is the main ECU. It looks really nicely made. And when I compare it to the original ECU made by MBE, there's not a lot of difference in size, which is really good for installation. In fact, it's slightly smaller. Next out of the box is the computer patch leads. These connect to the laptop PC to the main ECU for programming. And also a little USB stick with the program. First thing I need to do is identify the colours of the wires that go to each of the 8 injectors. This is a sequential injection system, so each injector is fired individually or in banks of 4. Here we can see the wire colour for injector number 1 is black and blue. That's black with a blue tracer. I can smell something nice coming from the kitchen, so I go to have a quick look. And Tracy's been doing some cooking, and this time she's making some ginger nut biscuits. She's already started and the mix is in the mixer going round. But all the ingredients are still lined up in a row by the window. She's got 2 baking trays prepared. That means she's making 2 batches, which is really cool. The mixer comes to a slow and controlled stop. No need for ABS on this machine. And she lifts up the top to have a quick look inside and it all looks great. So now it's time to add some golden syrup. This is quite tricky to do because it wants to stick to the spoon, but it runs out eventually with a bit of help. Then she closes the mixer and gives it another whir for a few minutes just to make sure it's all into a nice consistent paste. After a short while, all the golden syrup's been nicely mixed into the powder. This is now ready for squeezing into a big lump, picking up all the bits and putting it down to a plate. Then using a sharp knife, we can cut it up into individual biscuit-sized pieces, ready for putting on the baking tray. This is not an exact science and just done by eye. All the lumps then roll into nice balls, press onto the greaseproof paper on the baking tray, squidge down with a spoon, put in the oven, and then when they come out, they're nice golden brown ginger nut biscuits, just ready for eating once they've cooled down. And here they are, piping hot ginger nut biscuits, ready for cooling down. I'm under strict instructions not to touch when I take one now, so I go back out in the garage to get on with the wiring. I pick up the main wiring loom that's come with the ECU kit and start identifying the wires. That's the patch lead that connects to the laptop with a serial connector on the end. They provide a special serial to USB converter lead, which is really cool as well. With the first wire identified, I measure it out against the red power lead for one of the connectors and cut it to length. This would be the switched earth wire controlled by the ECU to make the injector fire. With the wire cut to length, I can now crimp on the new connector and solder it in place. Then slide the connector into the connector block, listening for the click as it securely goes into place. With both the wires positioned into the connector block, the next thing to do is put some heat-proof sleeving over the wires to protect them from the heat from the engine. This slides on nicely. I'll now repeat this process for the remaining 7 injector plugs. The next thing to do is to connect the injector connectors up onto the injectors and feed the wires right neatly across the top of the engine, ready to connect into the main loom. With all the connectors connected to the relative sensors and injectors, and these are the 2 coil packs at the back, it's now time to start making the main loom. But I just noticed I've forgotten to connect up the air temperature sensor, so I'm going to mount this on the front of the frame. There's already an existing hole in the frame to use, so it just bolts on nicely. I look in the manual, and the next thing I need to do is fit the 4-way fuse block to feed the main ECU. This mounts nicely onto the frame. I then mark out the 2 securing holes. With the 2 holes drilled, I use my garage vacuum cleaner to suck up all the swarf. Then, following the diagram in the instruction manual, I wire up the main fuse box. The remaining wire is the switch to feed from the ignition switch. This energises the relays to connect the main ECU to the battery. So all that remains to do now is connect up all these sensors into the main wiring loom, following the instructions in the manual to get the right colour wire to the right sensor. So I now connect up the main ECU wiring connector with all the wires. Then I spend some time sorting out which wire goes where by its individual colour code and connecting up to each relevant sensor or injector. This takes several hours. With the main loom cut down to length and connected up, I use some special resin-impregnated cloth wiring loom tape. I wrap the tape round and round the wiring loom with a slight overlap in each revolution. Then when it's finished, you can squish it all down with your fingers and make all the resin soak through and make it glue nice and tight. It looks a really professional job when it's done. Well, that's the first stage done. It's now got to do the fiddly bit going around all the injector wires and the sensor wires. But after a bit of perseverance, it doesn't take that long, and now it's looking really good. I'm well pleased with that. With the wiring complete, it's time to turn on the ignition for the first time and see what happens. So I turn the key, and straight away the red light comes up on the ECU, which is a good sign. I bought this cheap laptop online, especially for the Norton Nemesis that stayed with the bike, and on this is loaded the software for the Canems ECU. So now it's time to connect it up to the bike and see what parameters we got set. I click on the Canems icon and open up the mapping software and open up the main dashboard, because the first thing I need to do is set the throttle position sensor for maximum throttle and minimum throttle. I do this by turning the throttle and holding it up pretty wide open and clicking accept settings, and then let it idle and click set settings. With the throttle position sensor set, I can now check the air temperature sensor by heating up the hairdryer and watching the gauge go up, which it does, which is just perfect. I noticed that the coolant temperature gauge is on 0, which is a bit strange. It should read ambient temperature when it's not being used, which would be around about 16 degrees. So I checked the output with my meter and it's out of range, so it needs to be replaced. I unplug the connector, unscrew the temperature sensor and replace it with a new one. I had to be really careful removing the sensor, so I didn't want to drop it down the back of the engine and get it wedged in behind the exhaust system. It might be really hard to remove. Sensor removed, I place it next to the new sensor. It's slightly different in shape, but the connectors are the same and the thread's the same, so it should work hopefully. But I think I'll test it before I actually screw it into the bike. So I connect it up to the sensor connector, and immediately the gauge goes to 16 degrees, which is just perfect. So it shows it's working within the range. So to test it properly, I go in the kitchen, make myself a nice cup of tea, bring it back out into the garage with one of those nice ginger biscuits as well. They are so nice. I use the tea to test the sensor by dipping the sensor in the tea, which should be about 50 degrees. I'm observing the gauge, and yes, it goes up. So I'm really pleased with that. So now I've got a fully operational coolant temperature system. And the tea was really nice as well. The last thing I need to do is check that the ECU sends a little bit of fuel in when I first turn on the ignition, just to wet the inlet manifolds. This helps it start. The amount of fuel that squirts reduces as the engine warms up to about 0 when it's at 50 degrees. The ECU is installed with a base map for the main fuel injection part of this, so I have a quick look at the computer and it all looks quite nice to me. The numbers gradually increase as the throttle opens, and as the load increases they open even more. So this should work just good enough to make it start and run, and we can take it to a rolling road and give it a proper tune. So with no further ado, take the bike out in the garden and fit a pair of temporary silencers to keep the noise down and see if the engine will start. I'm about to push the starting button, and when I look up and see two pigeons looking down, they don't look impressed. I'm really pleased with that. It's not running too bad for its first startup on its base map. I'll make a few minor adjustments to the fuel enrichment, and it's all ready to take up to the London Motorcycle News show. Along with the Nemesis, I also took my 698cc V-twin Velocer.
So here we go, the Nemesis at the London MCN Motorcycle Show here. How about it, ladies and gentlemen? That thing is ridiculous.
Well, thanks for watching. I hope you enjoyed it, and I'm really excited now. The Nemesis is running quite well, so the next thing to do is to get it to a track or a rolling road for some proper testing. We've had quite a mild winter this year, and the hedgehogs seem to have come out of hibernation early. They're charging around at night, making loads of noise and eating all the food.